Hello, I am Hassanul Banna Himel, currently studying in Brack University. I am currently at first year. This is linear algebra for AI and ML. We're running a marathon from day 7 to day 12, or we started it on previous Sunday, and it will be finished on this Friday. This session is fully supported by global AI community, our local community dev change makers, and also NSDC and TensorFlow user group Bangladesh. Today is our day 9, and today is May 21st, 2024. And what were the concepts, or what were the contents we have learned, and what will be our learning today, and what we are going to learn in our future sessions. In the day 7, or on the Sunday, we learned about basis, orthogonal vectors, orthonormal vectors, generic tensor notations. Yesterday we learned about tensor transposition, our basic tensor arithmetic, tensor reduction, and the dot product. And in the from day 1 to day 6, we learned about matrix, what is matrix, what types of matrix are there, and what can we do with the arithmetic, like addition, subtraction, and multiplication. We learned about matrices. And today is our day 9. Today we will be learning about solving linear systems with substitution, solving linear systems with elimination, and we will learn something about Frobenius norm, and learn some code on NumPy. Now I'll start our today's session. As I said earlier, what we will be going to learn today, we're going to learn solving linear system with substitution and elimination, and finally we will learn the Frobenius norm. Now here comes the question: how can we solve a linear system with substitution? We all know there is a variable in system that has a coefficient of 1. Let's write a system here. Let's assume we have y, it is equal to x. Here our coefficient of y is 1, and let's assume we have another 1, 5x plus 2y is equal to. So how we can solve this problem? With the help of substitution method, we can see here our y's value is given here. Our y is equal 3x. So if we put our value of y in here in this line, we can solve it. Like, let's do it here. We have minus 5x plus 2 multiplied 3x is equal to. So we can see now we will have a minus 5x, and plus, when we multiply it, we will get 6x is equal to. So after doing this math, or after doing the 6x minus 5x, we will get x, and which is our value of our x. So x is equal to. Now we can put the value of x in here. While we do it, we will get the value of our y. So our y will be 3 times 2, and that will be 6. So we can say that our x comma y will be our 2 comma 6. So this is how we can we can solve the linear systems with the substitution method. If you have any questions, you can ask me anytime by raising your hand, or by unmuting yourself. So yeah, this was how we can solve the linear systems with substitution. So you can do some exercises here. I have given 3 exercises. You can do this one, like x plus y is equal 6, and we got 2x plus 3y is equal 16. You can solve this one, or you can do this one also, that where we have minus x plus 4y is equal 0, and 2x minus 5y is equal minus 6. And finally we got another problem here, like here we got y is equal 4x plus 1, and finally 4x plus y is equal 2. So the problems are given here and the solutions are also given here. The solution of first question will be, we got our x will be 2 and y will be 4, and our on the second math we will get, on the x we will get minus 8, and on the y we will get minus 2, and there will be no solution in the third question. Now let's move on to our second part of today's session. So what we got here, now we will be doing the solving our linear systems with the elimination method. Typically it is best option if no variable in the system has coefficient of 1. In the earlier we have seen that our this has a coefficient of 1. When we have a coefficient of 1, we don't write it down, right? So what happens when we have a variable, there is no variable with the coefficient of 1, we will use the elimination method. Now let's see an example. Let's assume we got a system here, 2x minus 3y is equal 15. Let's assume this as our equation 1, and here our second one is 4x plus 10y is equal 14. Let's give it a second equation mark. These equation marks are for myself, so it will be easier for me to solve these problems, right? So now let's solve this one. Here we can do that. If I multiply my first equation with minus 2, we can eliminate this, right? Like if I multiply this with negative 2, we will get a negative 4. So if we multiply our equation 1 with negative 2, what will we get? We will get a equation of minus 4x plus 6y, and it will be equal minus 30. And when we got our second equation, it will remain same. It is 4x plus 10y is equal 14. So now we can do the simple elimination. We can cancel out this part and this part, as these all are same, and here we will be remain with 16y, and here we will be remain with minus 16. So for the next part, we got our 16 here. So if we divide the whole part with 16, we will remain with y is equal our negative 1. So we got the value of our y. So now we can put the value of y in anywhere to find the solution. Let's get it into our equation 1 or equation 2. You can put it down anywhere. Let's put our y into our equation 1. We will get a 2x minus 3 multiplied by minus 1 is equal 15, and then we will get 2x plus 3 is equal 15, and then finally, after doing the whole process, we will be getting x is equal 6. So this is how we can find the value of x and y, or the value of our variables with the help of the elimination method here. So our value of x is 6 and our value of y is -1. Hopefully it is clear to you. So yeah, next, now move on to again exercise part. You can take screenshot, or you can uh, take the slides. I will give the slides folder to you, so thus it will be helpful for you to solve the problems. So yeah, here is our 4x minus 3y is equal 25, and another equation is minus 3x plus 8y is equal 10. You can do this, and this will got no solution. You can find solution for this one, and finally you can do this one too. And again, here you got solutions. So if you are confused with how to do this, or if you confused with your solution, you can check it also with yourself. So now today is our final part, or the third part. In this marathon we are trying to solve the linear algebra part, right? So from day 1 to day 12 we will be doing all the linear algebra part which is needed for machine learning, and then from further on we will learn statistics, and we will learn about probability, we will learn about calculus, which parts is needed for our machine learning. So uh, let's continue the Frobenius norm. So what is the Frobenius norm? The Frobenius norm of a matrix is a measure of the size of the matrix. It is defined as the square root of the sum of the absolute squares of its elements. Mathematically, if A is an m multiplied n matrix with elements of A subscript I and j, here our, let's assume A is our matrix, this is our number of row, and this is our number of column, and the Frobenius norm will be norm AFA, and it also analogs to L2 norm of vector. We learned about L2 norm in our maybe our day 5 or day 6 as much I remember. And finally, it the measures of the size of matrix in term of Euclidean distance. We all know about what is Euclidean distance, right? It's the sum of the magnitude of all the vectors in X. So it is also described as this way. You have a matrix here, superscript F, root over sum of X I j square, or this is denoting as our L2 norm, and we got here I and j. So this is the equation for our Frobenius norm, or this equation is we're going to do with our machine learning maths. So now let's see some math problems so we can learn about more. So I am hoping that you can see my screen. For mathematics, we are going to use NumPy in this series, and later on we will be using TensorFlow, so which is provided by Google and machine learning library. We're using NumPy for simple use. At first, let's me connect my Colab. It is connecting. Yeah, it is connected. At first we will run our numpy cell here. We're importing numpy as np. It connected. Now we're here, we got a matrix it is np dot array, all is denoting as array. We got an array of 1 2 and 3 4. Now when we run this cell, we will get the value. Here we are getting, it is showing us the array of matrix our 1 2 3 and 4. And finally, how to find the Frobenius norm. To find the Frobenius norm, we can use this method. It is np our numpy dot lineal dot norm, and in the here we are passing our x or our array here. So while we run this cell, we will get the Frobenius norm of or all the summation or the root over of the summation. It will give us a 5.4722257 or something, like it will give a large amount of number to you. So this was today's part, or this was the part which we were learning today. So today we learned about how to solve the problems with substitution method, how to solve it with elimination method, and finally we learned about the Frobenius norm, and also it is analogs to our L2 norm of vector. And finally, this is the conclusion. If you have any questions, you can ask me now.